Welcome to the course, Blockchain Basics and Beyond. My name is Anish and I will be your instructor for this course. For the blockchain enthusiasts, blockchain technology is the next big thing after internet. For the less so, it is just a hype. Most of us fall somewhere in between. But irrespective of which side we are, blockchain is definitely not something that we should be ignoring. Blockchain technology is increasingly getting employed in various industries, and together with other emerging technologies like machine learning, artificial intelligence, blockchains will have a disruptive impact on how businesses are being run. It will also create new opportunities. So it is important that we remain informed about blockchain and its developments. This course is a non-technical approach towards understanding blockchains and its uses. We will not have any coding. Instead, we will try to understand the various underlying concepts in blockchain and its use cases. We will learn more about Bitcoins and also the industry-wide application of blockchain technology. This course is split into 4 parts. In section 1, we will introduce you to the underlying concepts of blockchains. What is a block? What are distributed ledgers? What is a cryptography, immutability, public and private key, among other things. Section 2, we will focus on Bitcoins, which is the most known use case of blockchain. We will learn about the underlying concepts behind Bitcoins, its life cycle, what is a wallet, what are nodes and miners, what is Bitcoin halving, and also what are the various issues and concerns with Bitcoins. Section 3, we will introduce you to the other terms often associated with blockchains, like altcoins, stablecoins, ICOs, smart contracts, and NFTs. These are revolutionizing multiple industries. Section 4 looks into the industry-wide application of blockchains. We will focus on health, retail, insurance, and finance, and also learn on how blockchain is helping these industries to tackle the challenges faced by them. The course is designed for anyone who wants to understand blockchain without getting into the technical or technological aspects. The course will lay a strong foundation on which you can continue your learning of blockchains. Without further delay, let's get started. Welcome back. Before understanding what a blockchain is, it is worth looking at a use case of blockchain. This will help us understand how blockchain can tackle the challenges faced in that space. Let's take an example of a public distribution system. Most countries will have some form of a public welfare program. One of the most common form is where the government provides food grains to a particular section of its society at a subsidized rate. A typical example would involve government procuring food grains from the farmers and providing it to the eligible citizens of the country. This would be achieved by involving authorized parties to process, transport, and distribute the food grains. Similar to any other welfare program, there are various challenges faced by the government. These include ensuring that the leakages are minimal, ensuring that all the eligible citizens get the benefit and only the eligible citizens are getting the benefit, ensuring that all the parties have been fairly compensated, all the parties in the chain, have the exact details in terms of the inventory with each of these parties, ensuring that the quality is maintained, and finally, ensuring that all of this is achieved within a reasonable cost. Challenges are many, but there are 3 broad underlying issues: lack of transparency, difficulty in detection of fraud, and difficulty in getting the information quickly. Let's take this example a little further. Suppose government procures 500 kg of wheat from the farmers and sends it to its authorized processing units. The processing unit then processes the wheat and sends 480 kg to a transport company. Through the transport companies, the distribution companies receive around 450 kg. And of these, around 400 kg is received by the eligible citizens. In this example, we can see that around 100 kg of wheat is lost in leakage. Now, some of this could be genuine, while most wouldn't. The biggest issue that the government faces here is the lack of transparency in terms of where the leakage has occurred. And this is where blockchain technology can play an important role. What if all of these transactions are being recorded on a public ledger, which anyone can view and verify? What if these transactions are being linked to each other such that we can see the entire chain of events? And what if the ledger is made immutable, That is, it will be very difficult to change the records, and any changes can be easily detected. For example, when the data has been changed from 450 to 400, it will get highlighted. These changes will bring an immense transparency in the entire flow of transactions. This would also help with the detection of fraud and also make the data easily available. This is what blockchain brings to the table. So what is a blockchain? Though there is no single way to define a blockchain, it could be understood by understanding the various components of a blockchain. We will go through them in detail in the next few lectures, but let's quickly note them down here. Distributed ledger. One of the key aspects that differentiates blockchains from traditional database is its distributed nature. Compared to a traditional database where the information has been stored centrally, in a distributed network, the data has been saved across multiple computers. It's important to note that blockchain is not the only technology that's been based on distributed technology. There are others as well. The information is collected digitally and stored electronically in chunks, or what we call as blocks. Now, how much information a block can hold depends upon the used case of blockchain. For example, in case of cryptocurrencies, we could have 2,000 to 4,000 transactions in a block. In case of some of the private blockchains, it could just be a few transactions or maybe only one transaction. Third is the use of cryptography. The transactions in the blockchain or the blocks in the blockchain are linked to each other with the use of cryptography. Cryptography in simple terms is the use of codes to encrypt and decrypt data. This will enable that the data is being securely transmitted and stored. Again, cryptography is not limited only to blockchains. There are other technologies that use cryptography as well. The fourth key aspect of blockchain is that the ledger is immutable. That is, it is very difficult to change the record. This is primarily achieved via the use of distributed ledger and the cryptography. Let's say we add transaction 10 to this first block. This will result in the hash value of the block to be changed, which in turn will impact the link that this block will have with the other blocks in the blockchain. Also, all the transactions are required to be verified by the nodes participating in the blockchain, so any changes will get identified quickly. Since the technology is based on distributed network, where you have multiple systems in the network, the participating systems have to ensure that the transactions are verified and are in line with the blockchain rules. This will also include the decision on who will add the next block. All of this is been achieved by following a consensus protocol in the network. The other important aspect is security. With the use of public key and private key, digital signature, and cryptography in general, the blockchain network ensures that the data is securely transmitted and stored. Also, the identity of the participants is not compromised with. Application of all of the above points that we discussed depends upon where the blockchain technology is used. In case of a public blockchain, the information is available for anyone to view and verify. Private firms, on the other hand, cannot afford this level of transparency, and that is why they use private blockchains. Private blockchains put significant restrictions on who can view and verify the data. We could also have something called as a hybrid blockchain, which will have some of the features of both these models. So these are the 7 important aspects of blockchain. We will look into each of them in detail in the next few lectures. Thank you. In the last lecture, we briefly touched upon distributed ledger. Let's look at it in a bit more detail in this lecture. Before understanding what a distributed ledger is, it is worth understanding what are the other forms of ledgers. The first form is the centralized ledger. Under a centralized ledger, all the communication is managed by a central system. The individual systems do not communicate with each other directly, but they do it via a central authority or a system. The data is also controlled by this central authority. This helps with the centralization of data, but may also lead to a single point of failure. The second type of ledger is the decentralized ledger. Under this form, the workload is spread across multiple servers. The individual systems will communicate with the server and the server will communicate with other servers or systems linked to them. This brings us to the third form of ledger, the distributed ledger. Under the distributed ledger, all the systems will store the data and will communicate with each other directly. This allows us to eliminate the need of a central authority to manage the network. Anyone can add a new data, provided the other systems approve. Now, distributed ledger technology is kind of like an umbrella term that has been used for any network that uses a distributed ledger. Blockchain is one of the most known use case of distributed ledger technology. The individual systems are called as nodes. Now, it is not necessary that each node has to be connected to the other node. Even if they are connected to a few systems or few nodes, they should still be able to get all the information. Theoretically speaking, the entire blockchain can work on a single node, as each node will have all the data stored. But that will result in centralization, which is what we are trying to avoid. Now the question arises, why are we trying to eliminate the central authorities? And what are the issues with centralization? Let's look at some of the important reasons and see how distributed ledgers can solve those issues. Centralization results in the emergence of strong third parties. These could include banks, social media companies, and marketplaces. So the parties to the transaction will have to abide by the rules that have been laid down by these third parties. For example, let's say if two parties want to transfer goods with each other, they will have to abide by the rules laid down by the marketplaces. These could include high fees, preference for one supplier over the other, etc. Decentralized network will allow the parties to communicate with each other directly. This will eliminate the need for the central third parties. In today's world, a large amount of critical information is stored on digital platforms. Apart from the information being securely stored, the information should also be readily available. If the network is centralized and there is an outage, we will not be able to retrieve the information. In case of a distributed network, even if one node is up and running, the data can be retrieved. Digital systems are subject to both internal as well as external threats. From an internal perspective, we could have an employee committing a fraud. From an external perspective, we could have a hacker attacking the network. Both these could lead to a loss of data or a change to it. Distributed networks make it very difficult for both internal as well as external parties to amend the data, as they would have to attack the majority of the nodes. Another important area of concern is the ownership of data. Centralization of data could make the central authorities the owners of the data. They could sell or provide this information to others without the user's consent. By eliminating the central third party, the users could become the owners of his or her data and can provide it directly if required. Of course, we could have some regulations that could impact it overall, but by and large, the data will be controlled by the users. We will look at a used case of distributed ledger when we look at Bitcoins in the next section. Now let's look at what a block is in our next lecture. Thank you. Welcome back. In the last lecture, we looked at what a distributed ledger is. In this lecture, we will look at what a block is. A block is what holds the transaction, or where the transactions are bundled and stored into. A block may contain any kind of digital record. It could be a document, an image, a video, cryptocurrency, or any other kind of digital record. As we discussed earlier, what a block will contain and how much information it will hold depends upon the used case of a block. On a high level, a block will contain data, a transaction, or a set of transactions. For example, A transferred 1 Bitcoin to B. That is data, a transaction. Timestamp is the time when the block is created. Hash of the block is the cryptographic value of the block. We will look into how a hash is generated in our next lecture. Previous hash is the hash of the previous block. This helps the newly created block to connect to the blockchain. Depending upon the used case of blockchain, we could have a nonce, a transaction counter, and a magic number in a block. We will look at some of these in the next section when we look into Bitcoins. Now let's take an example to understand a block. Suppose there are 3 transactions in a network. A pays $10 to B pays $5 to C, and C pays $3 to D. Now let's assume that each block contains only one transaction. Now in a real world, we could have thousands of transactions in a block. Also, the transactions will not be this simple. But let's take this example for understanding what a block is. So based on the transactions, in the first block, we will have this transaction where A pays $10 to B. Now this was created on 1st September 9 a.m. So that's the timestamp on the block. The hash value is generated based on the data that is in the block. Since it is the first block in the network, we will not have any previous hash. The second block will have the second transaction. B pays $5 to C. The timestamp on this is 1st September 9:30 a.m. So this is when this block was created. Based on the information in this block, a hash value is generated for this block. In order to ensure that this block is connected to the blockchain, it will have a previous hash which will be the hash of the earlier block, that is block 1. This will enable that this block gets linked to block 1. The third block will have the third transaction. In case of this block, the previous hash will be the hash of block 2, and this will enable the newly created block to be linked to the earlier block. And thus this block will be part of this blockchain network. The way the transactions are being recorded as a chain of events or a chain of blocks is one of the other factors that makes blockchain different from the traditional database. By this way, we can easily determine the chronology of the events. Also, it will make it very difficult for anyone to amend the data. In our next lecture, we will look into what a cryptographic hash is. Thank you. Welcome back. In the last lecture on blocks, we came across a term called hash. In this lecture, we will look at what a cryptographic hash is and how it is generated. The term cryptography has Greek roots and means secret writing. In the past, it was used by military and intelligence agencies. Over a period of time, it has expanded into public sphere. As per Wikipedia, a cryptographic hash is an algorithm which takes an arbitrary amount of data and produces a fixed sized output of enciphered text. The text is called as a hash value or just hash. As we discussed earlier, a data could be any digital record, an image, a video, a document, a cryptocurrency, or any other digital record. Irrespective of what the data is or how big the data is, the hash output will be a fixed set of output. In this example here, we can see that we have a document here. Once we pass it to a hash function, it generates a specific fixed set of output. Now, if we replace the document with the image, we still get a fixed set of output. There are hundreds of cryptographic hash functions available. The common ones include the SHA family, that's the secured hashing algorithm. So you have SHA-1, 2, 256, etc. Then you have the MD algorithm, Blake, and Whirlpool. A blockchain network could employ any of the hundreds of cryptographic functions, hash functions available. SHA-256 is the one that has been used in case of Bitcoins. SHA-256 produces a fixed output of 64 characters. The hash function is used for various purposes and plays a very important role in a blockchain network. It is used to add a block to the blockchain. It is used for digital signature. It is used in consensus algorithm, and it has also been used to verify the blocks and transactions. Hence, it is very important that the hash function that is being used at least satisfies the below conditions. The hash function should be able to provide the hash value very quickly. This is very important as the hash has been used in various stages of blockchain and we do not want to create unnecessary delay due to a delay in the generation of a hash. Let's look at a tool that is available online to look at how a hash is generated. Now, there are hundreds of such online tools. I'm just using one of them. In this online tool, let's say if I type a word, let's say block. You can see that it quickly generates a hash output. If I change this word, let's say if I make it blockchain, it generates another output. And you can see how quickly this has been generated. The second important feature is that if the input is same, the output generated should also be the same. Let's go back to our example. So here we see that when we typed blockchain, it generated a particular hashing output. Now if I remove this, we can just note it here, EF7797 that it starts with. When I retyped it, it generated the same hash. This is very important as the hash is being used for verification purposes. Now, if the hash value generated is different for the same input at different times, then we will not be able to verify the record. The third important feature is that it is a one-way function. This means that the data input can be used to generate a hash output, but the output cannot be used to generate the input. This is very important as we do not want anyone to decipher the original data using this hash output. The fourth important function is what we call as the avalanche effect. Now when we say an avalanche effect, what we mean is that the hash output is completely different even if we make a slight change in the input. Now let's go back to our example. Now in this example, let's say if I just add one character to the end, let's say I just add a S to the end. Now by just by adding a S to the end, you can see that the hash output has changed drastically. So this was the original one, and here I just add a S. Now this is very important as we do not want anyone to second guess the data. If the output would have changed only slightly, let's say if I just added an S here and then only one of the digits at the end was changed, then someone would have been able to second guess the data using the hashing output. So in this example, if I add a period to the end, you can see that the output has changed drastically. Here's for comparison. The original data and one with a period, you can see that the output has changed drastically. The last important feature is that the hash function should be collision resistant. That is, two different inputs should not generate the same output, or at least occurrence of it should be extremely rare. We will look at cryptography in a bit more detail when we look at Bitcoins in our next section. Thank you. Welcome back. One of the important characteristics of blockchain is that it is immutable. The dictionary definition of immutable is something that is not capable of or not susceptible to change. In case of blockchains, by immutability, we are referring to blockchain ledger's ability to remain unchanged or unaltered. This makes it nearly impossible for an entity to manipulate, replace, or falsify the data stored on the network. Blockchain achieves immutability primarily due to two characteristics. One is the use of cryptography, and second is that the data is stored across distributed networks. Let us take an example to understand this better. We will take the same example that we looked into in an earlier lecture on block. As we understand, all these blocks are connected to each other through the use of cryptography. The previous hash of block 2 is the hash of block 1, and the previous hash of block 3 is the hash of block 2. This enables each of these blocks to be connected to the earlier block. We also understand from our previous lecture that the hash value is generated based on the contents of the block. So if we change any of the contents of the block, and that could be the actual transaction, timestamp, the previous hash, etc., the hash value will change. So in this example, let's say we amend block 2. We change the transaction B pays C $5 to B pays C $7. As we see here, with a change in the transaction, the hash value gets changed. Since block 3 was connected to block 2 by using the previous hash, because of the change in the hash here, block 3 is no more connected to block 2. So the attacker will have to rerun block 3 with a revised previous hash. So he will need to use the new hash of block 2 as a previous hash of block 3. But this will result in a change in the hash of block 3. So the attacker will have to rerun all the subsequent blocks to ensure that his change is not detected. This is very difficult and highly expensive. Apart from cryptography, the blockchain's nature of being immutable is also achieved through the distributed nature of its ledger. For ensuring the blockchain network works efficiently and that all the transactions are verified, there exists a consensus protocol in the network. This is also required to add a block. Unless the majority of the nodes agree, a change cannot be made. Now, if the attacker attacks the network, he will have to get the consent from the majority of nodes, or he needs to attack the majority of the nodes. This again is very cumbersome and expensive. Immutability is important for the network as that gives comfort to the participants on the accuracy and the authenticity of data. We will now learn about consensus protocol in our next lecture. Thank you. Welcome back. In this lecture, we will look at what a consensus protocol is. Even though there is no central authority, all the transactions in the blockchain network are verified and securely recorded in the ledger. This is because of the presence of a consensus protocol in the network. The consensus protocol or consensus algorithm is a procedure through which all the nodes come to an agreement on the current state of blockchain ledger. This can also be looked into as a set of rules that govern the network. The agreement also includes the decision on who will add a block. Being able to add a block is important to a node as that is how the nodes earn their rewards. Additionally, to ensure that the blockchain is secure and the data is not tampered with, a strong protocol is required. There are various consensus protocols. I have listed a few of the most known protocols. We will look at the first three in a little bit more detail. The proof of work is potentially the most known consensus protocol. The Bitcoin network utilizes the proof of work protocol. Under the proof of work, for a node to add a block, it has to solve a mathematical puzzle. The node that solves the puzzle the first will be allowed to add a block. Let's look at how it works. To create a block, the nodes need to first bundle the transactions and create a block header. This is then passed on through a hashing algorithm. The hash generated is checked against the puzzle. If the hash generated solves the puzzle, the node will be allowed to create a block. If not, then the node will have to rerun the hashing algorithm. Now we understand that if a data input is the same, the hash output will also be the same. So the node has to change the inputs. The most common way is by changing the nonce, or by changing the set of transactions that have been compiled to create the block. The process will continue until the hashing output meets the puzzle's requirement. We will expand on this further and also look at what a nonce is when we look at bitcoins in our next lecture. The nodes have to keep rerunning the process. Hence, the nodes with the highest computational power will have the highest probability to solve the puzzle. Since all the nodes that are trying to add a block are performing this activity, and all of them require a high computational power, this protocol is also highly energy intensive. Under the proof of stake protocol, a random algorithm picks up the node that will add a block. Under this protocol, the participants are required to put in some coins at stake. The algorithm will choose the node based on the value or the aging of the stake or a combination of it along with other factors. If the stake is greater than the target, then the node will be picked to create a block. If not, then the node can wait for the next round. In this approach, the nodes are not required to solve any puzzle. Hence, there is less energy consumption. However, the computational power is replaced by the currency power, as the nodes are required to put in some coins at stake. If the selected node cheats or is unable to perform, the node will lose its stake. This hinders the hackers from attacking the network, as they could lose their stake. Under the proof of authority mechanism, a designated number of nodes are permitted to validate the transaction and add a block. There is no competition between the blocks, and these are primarily used in private blockchains. These are more scalable, that is, the network can add a lot more blocks as less time is spent on the validation process. In the next lecture, we will look at security. Thank you. Welcome back. In order to ensure that the data is securely transmitted and stored on the network, it is important to have a strong encryption methodology. There are broadly two categories of encryptions: symmetric encryption and an asymmetric encryption. Blockchains could employ either of them, though asymmetric encryption is considered to be more safe. Let's look at both the forms. Symmetric encryption is an encryption methodology where the same code is used to encode and decode the data. For example, Alice wants to send a document to Bob. Now, Alice and Bob are the most common names being used, so we're just using the same names here. Now, Alice needs to send this document to Bob. In order to ensure that no one else is able to access the document, Alice will password protect the document. Now, this file can only be opened by using the same password. However, this will require Alice to share the password with Bob. This means that the data is susceptible to an attack by a hacker. The other form of encryption is the asymmetric encryption. Under this model, the sender and the receivers use different codes or keys to encode and decode the document. This is achieved with the use of a public and a private key. Let's take an example. Again, suppose Alice is the sender. Alice will have a public and a private key. These two keys are connected to each other mathematically. So if the document has been encoded by one of the keys, then it can only be decoded using the other key. As the name suggests, public key is something that can be shared, but private key, like a password, cannot be shared. Similarly, Bob will also have his own public and private key. Now, Alice needs to send a document to B. Both Alice and Bob will have their own public and private keys. In this case, Bob can send his public key to Alice. Alice will then encrypt the document using Bob's public key. This document can now be decoded only by using Bob's private key, which only Bob will have access to. This will make the data transfer very secure, as there is no sharing of password involved. Asymmetric encryption makes the data transfer safer, but how do we authenticate the sender of the document? This is where digital signatures play an important role. Digital signatures play the same role as handwritten signatures and has been used for verification of sender. The main purposes of digital signature are authentication of the sender. In our example, it will authenticate that it was Alice who sent the document. Non-repudiation, that is, the sender cannot later deny that he or she has not sent the document. And third, it ensures the integrity of the document. Let's take an example to understand how this works. So Alice and Bob have their own public and private key. Both Alice and Bob will share their public keys with each other. Alice will then use Bob's public key to encode the data. Alice will then digitally sign the document using her private key. Bob will use Alice's public key to verify the sender of the document. So Bob will use this public key to verify the document and who the sender is. Bob will then use his private key to decode the document. The combination of asymmetric encryption and digital signature help achieve the below. First, it helps with the authentication of the sender. Second, it ensures that the data is received by the intended recipient. It ensures that the integrity of the document is maintained. Non-repudiation. And it's a secure way of transferring the data. Now in our next lecture, we will look at what a public, private, and hybrid blockchains are. Thank you. Welcome back. Application of the various aspects that we learned in the last few lectures depends upon the used case of blockchain. That is, where is it applied? Broadly speaking, there are three categories of blockchains: public blockchain, private blockchain, and hybrid blockchain. In a public blockchain, anyone can add and verify the data. Public blockchains are also called as permissionless, as there is no central authority to control the network. The network is controlled by the use of algorithms and consensus protocol. The nodes can have the same rights and authority. However, in practice, different nodes play different roles in the network and hence have different rights and privileges. Public blockchains are the closest to a fully decentralized model. The transactions and the communication between the nodes is peer-to-peer. Due to the existence of a consensus protocol and the additional checks in a public blockchain, the public blockchains are slower and are less scalable. The best known example are Bitcoin and Ethereum network. Private companies cannot have the same transparency as offered by public blockchains. Hence, they can employ a private blockchain. In a private blockchain, the participation is restricted. Private blockchains are also called as permissioned blockchains. Private blockchains are controlled by a central authority and the accesses are restricted. They cannot be treated as a fully decentralized model. However, these are faster and more scalable and less time is required on consensus. Quorum by JP Morgan is a private blockchain. Hybrid blockchains attempt to use the best parts of both public and private blockchains. They are highly customizable. These would have central authority with oversight responsibilities, but they are more flexible compared to a private blockchain. The participating nodes will have different levels of accesses depending upon their role. Compared to a public blockchain, these are more scalable and faster. The best known example is an IBM food trust. To summarize what we learned in this section, in blockchain, the information is collected and stored digitally. The data is stored in chunks in what we call as blocks. The blocks are time-stamped and are linked to each other chronologically. The data is stored in a distributed network and the nodes communicate with each other directly. This allows for the elimination of central third parties or central authorities. Blockchains use cryptography extensively, thereby enabling security and immutability in the ledger. The blockchains can largely eliminate the requirement of a central authority and replace it with algorithms and protocols. This enables for the verification of data and maintaining the authenticity of the network. Since there is no need to trust a central authority, blockchains also help in building a trustless network. Strong and secure protocols help with the strengthening of the network. The public blockchains helped making blockchain technology more popular. It is growing in importance in private sphere. With this, we come to the end of this section. In the next section, we will learn about the best known example of public blockchains, the Bitcoin network. Thank you. Welcome back. We are into our second section of this course. Bitcoin is one of the thousands of cryptocurrencies created and is one of the several thousands of blockchains. But in terms of market value, it dwarfs every other cryptocurrency and is also the most well-known public blockchain. So much so that sometimes people confuse blockchains with bitcoins. In this section, we will learn about bitcoins, its origin, how they work, what problems it solves, and what are some of the key issues and concerns with Bitcoin. When we say Bitcoin, it could mean different things to different people. For most, Bitcoin is a currency or a digital asset, also called as BTC. For some, it could be the network. For some, it could be the protocol that has been followed in the network. And for the rest, it is the software that runs the Bitcoin protocol. In this course, by Bitcoin, we are referring to the digital asset unless we specify otherwise. We can understand Bitcoins by breaking it down into different aspects. So Bitcoin is a digital asset. You may call it a currency or a token, but these terms could also be a bit misleading. So we look at Bitcoins as a digital asset that is perceived to have a value and that can be used as a medium of exchange or an instrument of investment. Bitcoins are recorded on an electronic ledger, that is, on Bitcoin's own network or blockchain. The creation of Bitcoins and the validation of transactions is followed by following a certain set of rules on the network. These are referred to as Bitcoin's protocol. Bitcoin protocol works on the Bitcoin software. Bitcoin software is an open software and there are multiple softwares available. However, some are more commonly used than the others. The transactions are validated by the nodes which run on the Bitcoin software. There is no central authority that creates or controls a Bitcoin or its network. Bitcoins were invented by Satoshi Nakamoto. The identity of Satoshi Nakamoto is still not known. Whether it was one person or it's a group of people is also not known. The concept of Bitcoin was brought out in a white paper released by Satoshi Nakamoto. It is a 9-page document and a quick read. I would suggest you read that document, but for this lecture, I'll highlight some of the important points. At the time of publication of the white paper, there were digital and online payment systems available. However, they all used some form of an intermediary, that is either a bank or a government institution. Now, this required parties to have a trust in the intermediaries to ensure that the transactions were authorized and that no fraud was involved. The goal of Bitcoin was to create a peer-to-peer transaction without relying on a central authority. The transactions were immutable and cannot be reversed. As you would see later in this section, Bitcoins do not fully eliminate the need of intermediaries, as we still need miners to create a block. But still, the network is peer-to-peer and there is no central authority that controls the transaction. Satoshi Nakamoto looked at Bitcoins as a chain of digital signatures. The transaction will be visible to all the parties and will be time-stamped. This eliminates the issue of double spending and reduces the chances of fraud and unauthorized transactions. In the white paper, Satoshi Nakamoto also discusses on the purpose of cryptographic puzzle, the nodes, and the consensus between the nodes. The concept of mining and incentives to miners is also been introduced here. We'll go through them in detail in some of the lectures in this section. In traditional banking, both the parties as well as the transaction between the parties is known to the central authority. But the public is not aware about the transaction. In case of Bitcoins, the transactions are public, but the identity of the parties is kept anonymous. The puzzle will be difficult to solve, but will be quick to verify. This helps in reducing the time spent on the validation. Now let's quickly look at the history of Bitcoins. The white paper was released in late 2008. The first block was created by Satoshi Nakamoto in 2009. The first block generated around 50 Bitcoins. This block is also called as the Genesis block. In March 2010, the first Bitcoin exchange was launched. The exchange rate back then was around 0.3 cents per Bitcoin. So you could buy around 335 Bitcoins for $1. Later in 2010, the first commercial transaction using Bitcoins was done. The user posted on the Bitcoin forum that he would pay 10,000 Bitcoins for 2 large pizzas. A person on the forum got 2 pizzas from Papa John's delivered for him. Of course, now 10,000 Bitcoins are worth hundreds of millions of dollars, but back then it was just worth 2 pizzas. Between 2011 and 14, the usage of Bitcoins grew, but it also attracted a lot of controversies. There were a large number of criminal activities involving Bitcoins. We will discuss about it in the later part of this section. From 2014, we also saw large corporations showing interest in Bitcoins. Microsoft was one of the early companies showing interest. Also, there has been an increasing regulations around Bitcoins, with some countries even banning it. Now let's delve deeper into Bitcoins in the next few lectures. Thank you. Welcome back. Before delving deeper into Bitcoins, it is important to understand the life cycle of a Bitcoin transaction. This will form the basis on how we will approach the rest of the lectures in this section. We will delve into depth into each of these components in the next few lectures. When Alice needs to send Bitcoins to Bob, she will use a cryptographic wallet. The wallet holds the public and the private key of Alice. Alice will then provide Bob's address, which is more like an account number and has been derived based on Bob's public key. Alice will then provide the amount and the fees associated with the transaction, and then the transaction gets relayed to the memory pools. The miners will collate the transactions from the mempool and try to create a block. To create a block, a miner needs to solve a cryptographic puzzle. The miner that solves the cryptographic puzzle the first will create the block. The block is verified by the other nodes and then added to the network. The miner who created the block will earn rewards in the form of Bitcoins that will be mined as part of the block, and also the fees that have been included as part of the transactions. Once the block has been verified by all the nodes, the transactions in the block will get confirmed. This will also include the confirmation to Bob. Now let's look at each of these in detail in the next few lectures. Thank you. Welcome back. In this lecture, we will talk about crypto wallets and how transactions are recorded on a crypto wallet. In case of traditional money transfer, we need to open a bank account. So in our example, Alice will need to open an account with a bank. The bank will help set up the password, and using this account, Alice can transfer the funds to Bob's account. Bob will be able to access the funds using his bank account. Now, if you're planning to use a cryptocurrency, even before you decide which cryptocurrency to use, you will need to open a crypto wallet. A crypto wallet is a software program or a physical device that will hold the user's public and private key. The wallets do not store the cryptocurrencies. The cryptocurrencies are stored on the blockchain. Wallets will store the public and private keys, which will allow the user to access the cryptocurrencies that are associated with the user's address. The key on cryptocurrency will look something like this. Most wallets will allow the use of multiple cryptocurrencies or tokens. Broadly speaking, there are two types of wallets: a hosted wallet and a non-custodial wallet. Hosted wallets are the ones where the wallets are held on the exchange where the cryptocurrencies are bought or sold. In case of the hosted wallets, the passwords or private keys are held on the exchange. This makes it vulnerable to attack by hackers, but on a positive note, even if you forget your private key, the exchange can help you retrieve it. An example includes Coinbase wallets. In case of non-custodial wallets, the private key is held by the user. This is safer, but if the private key is lost, the user will not be able to retrieve it. Non-custodial wallets can be classified into a hardware wallet and a software wallet. A software wallet could be a mobile app, a desktop app, or could be web-based. In case of crypto wallets, the transactions are recorded a bit differently. In case of traditional banking transaction, a transaction gets added or deducted to the pool of funds or the existing total balance. There is no direct link between the amount that has been withdrawn and the amount that has been added. In case of crypto wallets, there is a concept of unspent transaction outputs, also called as UTXOs. UTXOs represent the balances in the wallet, but instead of being represented as a total balance, these are represented as a set of transactions that have not been spent. So if a new transaction gets added, it will get added to the list of UTXOs. Now, if Alice wants to make a payment, let's say Alice wants to pay 0.5 BTC to X. Then Alice will need to decide which UTXO she wants to utilize. In our example, Alice can choose from any of the four unspent transactions. And let's suppose Alice chooses the third transaction. In this case, the third transaction will get dropped off, and this will be utilized for making the payment. Now, as we see that the requirement is only for 0.5 BTC, whereas the unspent transaction that is being utilized is 0.9 BTC. So we are left with 0.4 BTC. Now this Alice can send to herself. After this transaction, the revised set of UTXOs will look something like this. So here we can see that the first two transactions and the fourth transaction are the same. And then we have a new transaction, which is what Alice sent to herself, 0.4 BTC. Now let's say Alice wants to make another payment, and let's say for this time it's 0.65 BTC to Y. Again, Alice can choose any of the UTXOs or a set of UTXOs. So let's assume that Alice decides to use the first, the second, and the fourth UTXO. These three UTXOs will make it 0.7 BTC, which will still be higher than what is required to be paid. So for the additional component, Alice will pay that back to herself. So now the new set of UTXOs will look something like this. The wallets will allow the users to drill down and look back into transaction and see how this was being generated. Now let's see how the concept of private key, public key, and digital signatures have been implemented in Bitcoins. We'll look into it in our next lecture. Thank you. Welcome back. In the previous section, we looked at how private key, public key, and digital signatures work. To quickly summarize, in our example, Alice will use Bob's public key to encrypt the document. Then she will use her private key to digitally sign the document. Bob can then use Alice's public key to verify the digital signature and his own private key to decode the document. In case of Bitcoins, the transactions are not encrypted. They can be viewed by anyone who is there on the network. So in our example, Alice will provide Bob's address and use her private key to validate the transactions. The transactions will then get relayed onto the network, where they can be verified in the network by using Alice's public key. Once a transaction has been verified, it will be included in the block by the miners, and once the block has been created and added to the network, Bob will receive the confirmation. In our next lecture, we will look at the different types of nodes that exist in the Bitcoin network. In the later lectures of this section, we will also look at how miners pick up the transaction and how a transaction gets added to the block. Thank you. Welcome back. Now let's look at the different types of nodes that exist on a Bitcoin network. Bitcoin nodes are computer systems that are connected to the Bitcoin network. They perform the task of validating, broadcasting, and storing the transactions on the network. However, not all the nodes perform the same role. The main types of nodes that exist in the network are full nodes, miners, and light nodes. Now let's look at them in a little bit more detail. Full nodes store the entire Bitcoin blockchain and can verify all the rules of the Bitcoin network. A full node checks the validity of the transaction against the Bitcoin's history. They store all the Bitcoin transactions right from the first block that was created by Satoshi Nakamoto. To act as a full node, a computer needs to have a large storage capacity. It is estimated that there are over 7,000 to 10,000 full nodes in the Bitcoin network, though some reports put the numbers higher. Similar to the full nodes, miners are also involved in storing and validating the data. What miners additionally do is that they are also involved in the creation of the blocks. To add a block, a miner is required to solve a cryptographic puzzle. The miners are incentivized for the efforts via the block rewards. Block rewards include the bitcoins mined when the blocks are created and added to the network, and also include the fees that have been associated with the transactions. We'll learn about the cryptographic puzzle and how miners pick the transaction in our next few lectures. Light nodes run a special version of Bitcoin software that stores a lightweight version of blockchain. This allows light nodes to connect to the network and to also transact on the network. They are not required to store the full history. Light nodes cannot independently verify the Bitcoin network rules and will have to connect to a full node. Mobile wallets are a common example of light nodes. Now there are various other types of nodes as well, like pruned nodes, super nodes, archived nodes, lightning nodes. they are less important from our perspective here. In our next lecture, we will look at what mining is and how miners pick up the transaction. Thank you. Welcome back. In the previous lecture, we looked at various types of nodes and briefly touched upon miners. In this lecture, we will look at how miners pick the transactions. When Alice sends the money, it gets relayed into the network and the transaction gets captured in the mempool or the memory pool of the 4 nodes. Of course, the transactions have been verified in the network, which checks for the validity of the transaction and other things. The miners will pick the transaction from the mempool and then try creating a block. Now let's take an example. Let's assume there are 5 transactions in a mempool. In practice, there will be thousands of transactions. Bitcoin blocks generally have 1 MB worth of data, which roughly translates into 2000 transactions in one block. So a mempool will generally have thousands of transactions. But for our example, let's assume that we have 5 transactions in the mempool and the miner picks up 2 transactions. Generally, the sender will include a fee with the transaction. Fees are not mandatory, but fees form a part of the block rewards for the miners. So if no fees have been added, there is a high probability that the transaction will not get picked. Along with the transactions, the miner will also add the hash of the previous block. There will also be a timestamp, which will be the time when the block has been created. Nonce is a number that is added to the block along with the other fields. We will learn more about nonce in our next lecture. But for this lecture, it is important to understand that a nonce is a number that can be changed by the miner. Now there are other parameters like magic numbers, transaction counter, etc. But they are of less relevance for our purpose here. Once a block header has been created, it has been passed through a hashing algorithm. In case of Bitcoins, the hashing algorithm used is SHA-256. SHA-256 generates a hash of 64 characters, where each character could be anything between 0 to 9 or alphabets A to Z. If the hash generated is less than the target, then a new block is created. If the hash generated is higher than the target, then the miner will have to rerun the algorithm. For ensuring that a different output is generated, the miner will have to update the nonce in most cases. This process will continue until one of the miners solves the cryptographic puzzle. In our next lecture, we will learn more about the cryptographic puzzle and why is it required. Thank you. Welcome back. In the previous lecture, we looked at miners and how a miner is required to solve a cryptographic puzzle. In this lecture, we will try to understand the cryptographic puzzle a little bit more. Before that, let's quickly look at what the term nonce is. We briefly touched upon it in the last lecture. Nonce is a short for a number that can be used only once. In finance and cryptography, a nonce refers to a randomly generated number that is used to verify a transaction. So an example will include an OTP number that has been sent to us while, let's say, resetting a password. In case of Bitcoins, a nonce could be any number from 0 to 2 raised to 32. So that we could have over 4 billion numbers. A miner reruns the hashing algorithm by updating the nonce. This will help the miner generate a different hashing output every time the nonce is updated. Now let's look at some of the main reasons why a cryptographic puzzle is required and what problem does it solve. Bitcoin is an open source and there is no central authority to control it. However, these are also susceptible to attack by hackers. The attack could be to maliciously add a new block or to amend the existing blocks. However, for adding a block, a miner is required to solve a cryptographic puzzle and has to expend a considerable amount of computing power. So this makes it expensive for an attacker as they will have to spend a significant amount of computing power as well. Also, because of the existing competition between the miners, there is a lower probability of a hacker being able to solve the cryptographic puzzle. The time taken to solve the puzzle also deters the attackers. The second issue that we see is the increasing in the computing power. The Bitcoin network tries to maintain the time to create a block at around 10 minutes. Of course, an individual block could take much less or much more time. But with the increasing computing power, there is a chance that the blocks are being created too fast. To control this, the Bitcoin network changes the mining difficulty after every 2016 blocks. Now, since it takes around 10 minutes to create a block, to create 2016 blocks, it takes around 2 weeks. If it takes more than 2 weeks to create 2016 blocks, then the difficulty of the puzzle has been reduced. On the other hand, if it takes less than 2 weeks, then the mining difficulty has been increased. Now the question arises, what if more than one miner solves the puzzle? In this case, both the miners can relay it to the network, and the nodes can add either of the block to the chain. When the next puzzle is solved, the chain against which the new block is added will confirm which block wins. The block that is not added is called as the orphan block and will get discarded. The transaction in this block will move back to the mempool. In our next lecture, we'll look at some of the issues faced by Bitcoins. Thank you. Welcome back. A very important concept to understand is the concept of Bitcoin halving. In case of Bitcoins, the maximum number of Bitcoins that could ever be mined is 21 million. This is built into the Bitcoin's code and this cannot be changed. Now, there are various theories as to why a limit was placed and will continue until Satoshi Nakamoto himself clarifies. But the belief is that this was done to ensure that the value of Bitcoin is maintained, and unlike fiat currencies, it does not depreciate. Till date, over 19 million Bitcoins have been mined. That is, over 90% of Bitcoins have already been mined. It is expected that by the year 2140, all the Bitcoins will be mined. Another important point to note here is that similar to how 100 cents make up $1 and how cents is the lowest unit of a dollar, in case of Bitcoins, Satoshi is the lowest unit of a Bitcoin. 1 Bitcoin is equal to 100 million Satoshi. That is, we cannot make a payment that is below 1 Satoshi. Now, the only way a Bitcoin is created is by mining new blocks. So to control the supply of Bitcoins in circulation, we will need to control the block rewards. The way this has been achieved by the Bitcoin network is by halving the block rewards. The rewards or the Bitcoins mined per block is reduced to half every 210,000 blocks. Since it takes roughly 10 minutes to mine one block, it will take around 4 years to create 210,000 blocks. In 2009, when the first block was mined, it created 50 Bitcoins. This was reduced to 25 Bitcoins in 2012, 12.5 in 2016, and 6.25 in 2020. It will be reduced to 3.25 in 2024 and will continue to halve until the Bitcoin mined per block is 1 Satoshi. Beyond that, it cannot be further halved. It is expected that this will be achieved by the year 2140, when the total Bitcoins in circulation will be 21 billion. Now the question arises, what will the miners earn as rewards post 2140? Now the expectation is that the miners will be compensated via the fees on the Bitcoins. Now let's look at some of the issues that have been faced within Bitcoin in our next lecture. Thank you. Welcome back. In the white paper that Satoshi Nakamoto released, he described Bitcoins as a new electronic cash systems that was peer-to-peer and would eliminate the requirement of a trusted third party. The goal was to build something that could be used for day-to-day transactions and also for very small amounts. The goal was not to create an instrument of investment. However, Bitcoins have not been able to meet many of its expectations yet. In this lecture, we can look at some of the issues faced by Bitcoins. One of the major issues faced by Bitcoins is the volatility in its prices. The price of Bitcoins have been highly volatile. When the first commercial transaction was done in 2013, you could only buy 2 large pizzas with 10,000 Bitcoins. Now this would run into millions. At its peak in 2021, the price of 1 Bitcoin was 61,000, and that quickly dropped to around 16,000 in 2022. And this is not the first time that it has happened. The volatility in prices has led to Bitcoins being not used for the day-to-day activities. This is primarily because the payer and the payee are not sure what the value of Bitcoin would be the very next day. On the other hand, people have tended to hold on to Bitcoins, expecting that it will increase in value. And that's why, even though there are over 19 million Bitcoins mined, only a small fraction has been getting used for payments. The second aspect is the scalability. On an average, one block is created every 10 minutes, and a block would have roughly around 2000 transactions. So on an average, 3 Bitcoin transactions can be performed in 1 second. The same for Visa or a MasterCard is over 5000 transactions per second. Also, even though it takes 10 minutes to create a block, the recipients are generally being asked to wait for the creation of 6 more blocks so as to be sure that the block doesn't get dropped. So even in the best case scenario, where a transaction is been picked up by the miner as soon as it has been done, it will still take an hour for the recipient to be sure that he will receive the amount. Now, during high volumes, it could take much longer and sometimes even a few days. So you cannot wait that long in many cases, especially smaller transactions, for example, like buying a coffee. The other important aspect is the fees. On an average, it takes around $1.8 per transaction. In the event of high volumes, it could be much higher. In 2017, when there was high volume, a transaction would cost you $55 as fees. Now, this deters people from using Bitcoins for smaller value transactions. One of the main reasons why Bitcoins get a bad name is because of the high energy consumption in the mining process. Back in 2009, you could mine a block with a laptop. Now you would need large systems with large computing power. So much so that the energy consumed on one Bitcoin transaction could be more than 10 years worth of an average household energy consumption in US. In fact, 1 year's energy consumption on Bitcoin mining is even greater than the energy consumed by Argentina in a year. The other thing that has given Bitcoins a bad name is its usage in criminal activities. One of the most known cases is the case of Silk Road. Now there you could buy anything that is not legal and pay in Bitcoins. Another known incident was Mt. Gox, which was one of the largest exchanges back in 2013. It was attacked by the hackers, and it is believed that somewhere between 650,000 to 850,000 Bitcoins were lost. Though around 200,000 Bitcoins were later on recovered, most of it is still lost. Mt. Gox had to file for bankruptcy in 2014. Not only these, there have been many big and small cyber attacks where the hackers have asked for Bitcoins or other cryptocurrencies in return. It might sound a bit ironic that Bitcoins were designed in order to keep third parties away. But Bitcoins have seen strong centralization in other forms. Due to the high energy consumption and large upfront cost, it is difficult for a single individual to be a miner. More and more, the mining has been taken over by large mining pools. As per BTC.com, the top 8 mining pools mined over 90% of the total Bitcoins mined by pools. In fact, in January 2023, Foundry USA and Antpool controlled around 50% of the hashing power. This has made these pools very powerful, and we cannot rule down a chance of being dominated by these major pools. Even though the Bitcoin software is open source, the software that has been primarily used is Bitcoin Core. Around 96% of the miners use this software, so in future, if there is some bug in this software, you could expect large number of miners being impacted. Not just the software, even the hardware, that's the ASICs and the GPUs, the market is dominated by large players. Bitmain sells around 2/3 of the hardware that's been used by the miners. Another point to note is that Bitmain also owns Antpool, which is one of the biggest mining pools. The overall mining activity is also concentrated in certain geographical locations. US, China, Russia, and Kazakhstan own over 70% of the hashing rate. This is primarily driven by low energy cost and easy availability of technology. There was a ban introduced in China a few years back on the mining activity, primarily because of the high energy consumption. It did bring down the mining activity in China materially, but it is still believed that it is a significant player. The concentration also extends to the ownership side. As per a study, around 10,000 individuals own over 5 million Bitcoins. That is, less than 0.1% of the participants own 27% of the bitcoins that have been mined. Bitcoins are also not as anonymous as they are thought to be. Authorities have been able to track down the people behind Silk Road and also some of the other fraudsters. Also, the open ledger helps track all the activities that have been associated with a certain address. So the bitcoins are not that anonymous as they were thought to be. Now this brings us to the end of this section. In the next section, we will learn more about stable coins, altcoins, NFTs, smart contracts, and some of the other topics. Thank you. Welcome to section 3 of this course. In the last two sections, we learned about the basics of blockchain and about bitcoins. In this section, we will delve into the other aspects of crypto and blockchain space. We will learn about altcoins, smart contracts, non-fungible tokens, and ICOs. These form the foundation of many of the use cases of blockchain. In this lecture, we will learn about altcoins. Altcoin is a short for alternative coins, and the term has been used for any cryptocurrency that is not a Bitcoin. Altcoins have been created as an alternative to Bitcoins or as an improvement on it. Some of the altcoins are specialized for a particular type of payments. Some aim to build on a platform for apps, whereas the others are focused on improving on the Bitcoin's flaws. Some of the altcoins have their own blockchain network, whereas some build on the existing blockchains. The most common known altcoins are Ethereum, Ripple, Bitcoin Cash, Litecoins, and a host of stablecoins. Back in 2015, Bitcoins would make up over 90% of the overall market capitalization of cryptocurrency. Since then, altcoins have been increasing in popularity, and now they make up for more than half of the overall market cap. At its peak, the total market cap of altcoins was around 1.6 billion. Some experts put the total number of alternative coins available to be around 19k, though it's only a fraction of them have some value. Now let's look at some of the more commonly known altcoins. Ethereum was created in 2015 and has become one of the most widely used blockchain platforms for developing decentralized apps. Ethereum is a network and its native currency is called Ether. In terms of market capitalization, Ether is the second largest currency. The fees paid on the network is called as gas, and the rate depends upon how busy the network is. The Ethereum network can be used for creating various applications, including decentralized finance, digital identity, supply chain management, and non-fungible tokens. One of the most significant features is the ability to run smart contracts. Now, Ethereum is not the only network where a smart contract could be run. Smart contracts could be run on multiple other blockchain networks, including the Bitcoin network. However, Ethereum is the most widely used network for smart contracts. Until mid-2022, Ethereum was primarily operating on a proof-of-work protocol. Since then, it has moved over to proof-of-stake protocol. There are many differences between Ethereum and Bitcoins. The biggest difference is in terms of the purpose of the two networks. The main purpose of Bitcoin is to enable users to send and receive digital currencies without intermediaries. Ethereum, on the other hand, is designed to act as a platform to build decentralized app and smart contracts. The use of Ethereum goes much beyond the digital currencies. The native currency on the Bitcoin network is called the Bitcoin. In case of the Ethereum network, it is called Ether, also called ETH. However, there are many other cryptocurrencies created on this network. The Bitcoin network utilizes proof of work as its consensus mechanism. Ethereum recently has moved onto the proof of stake mechanism. Another big difference is that the Bitcoin's supply is been capped at 21 million, with around 19 million in circulation. Ether doesn't have any such caps currently, but there are plans to restrict its issuance in future. Currently, around 130 million coins are in circulation. Taking a quick look at Ether's market cap and market price. Ether at its peak had a market cap of over $500 billion. More recently, it has dropped to around 200 billion. Similar to Bitcoins, its value is also been highly volatile. Ripple is another well-known blockchain network that is primarily used as a real-time settlement system for currency exchange and remittances. It was created in 2012. Ripple uses its digital currency called as XRP, and it's been used to facilitate fast and secure cross-border transactions. The XRP token acts as a bridge that enables the exchange of one currency to another in real time, without the need of intermediaries like banks or payment processors. It makes it possible for the businesses and individuals to send and receive money instantly with low transaction fees. In a traditional blockchain network, it takes several minutes and sometimes even hours to process a transaction. In case of Ripple, it only takes a few seconds. Ripple has gained popularity among financial institutions like banks and payment providers as a very cost-effective solution for cross-border payments. Over 300 million institutions, including the American Express and Standard Chartered Bank, have partnership with Ripple. Unlike Bitcoins, XRP is not mined. These are pre-mined at the time of inception. However, similar to Bitcoins, its price has also been very volatile. Similar to Bitcoins, Litecoin also is a peer-to-peer cryptocurrency that was created back in 2011. Compared to the Bitcoin network, these are faster and takes around 2.5 minutes per block. The transaction processing is faster and the transaction fees are lower. Similar to Bitcoins, Litecoins also have a cap. The maximum number of Litecoins that would ever be mined is 84 million. Of this, around 67 million is already been mined. At its peak, its market cap was above 25 billion. Similar to other cryptocurrencies, its price also has been very volatile. Apart from the ones that we covered, there are many other altcoins also available. Most of them do not have a value, and in general are considered to be riskier than Bitcoins. Due to the price fluctuations, these were seldom used as a means for exchange. This is where stablecoins are useful. We'll learn about them in our next lecture. Thank you. Welcome back. In the last lecture, we learned about altcoins. One of the major issues with cryptocurrencies is that their prices are highly volatile, and thus they are seldom used as a means of exchange. Stablecoins were created to tackle this issue. As the name suggests, stablecoins are coins whose value is pegged to another currency, commodity, financial instrument, or even other cryptocurrencies. A stablecoin could be backed by a fiat currency like USD, for example, Tether. These could be backed by commodities or stocks, for example, Tether Gold. The stablecoins could also be backed by more known cryptocurrencies like Bitcoin. So wrapped Bitcoin is an example of such stablecoin. And there are some stablecoins which are backed by algorithm. Compared to the other cryptocurrencies, stablecoins are less volatile and thus are more suitable as a mode of payment. They also allow the holder to have exposure to the other traditional assets, while at the same time help to stay away from the centralized systems. However, not all stablecoins are created equal, and hence it is important to understand what these coins are truly backed by. Generally speaking, these are more riskier than the traditional investments. Some of the risks include potential bugs and vulnerabilities, regulatory uncertainty, and these are also subject to market forces. If the coin is not fully backed by a strong underlying, there is always an opportunity to exploit the weaknesses. Of lately, we have seen the impact of the Silicon Valley Bank failure on the stablecoins. One of the biggest examples would be that of Terra. So understanding Terra a little bit more. Terra and Luna were sister coins on the Terra network. Terra was a stablecoin whose value was pegged to US dollar, such that 1 Terra was equal to 1 US dollar. However, Terra was not backed by US dollars, but by its sister coin, Luna. Between April 4th, 2022 and 12th May 2022, that's roughly 6 weeks, Luna lost 99.99% of its value. There was an impact on Terra, which lost its peg to US dollar and was worth only around 2 cents. This also had a domino effect over the other currencies, and the cryptocurrencies overall lost around $300 billion in market value. But then how did this happen? Terra USD's value was maintained through an algorithm. 1 USD could be exchanged for $1 worth of Luna. So suppose Luna was trading at $100, you could exchange 1 Luna for 100 USDs. If the USD loses its peg and let's say its value drops to 90 cents, there will be an arbitrage opportunity and people will try to convert the cheaper USD to a more expensive Luna. This will in turn increase the demand for the Terra USD and thus its price will increase and it will achieve its peg. So it was a mechanism in which a single algorithm was trying to keep two tokens stable. It worked well until it didn't. Now the question arises that Terra's value was backed by Luna, but why did Luna have a value? So Luna was used for various purposes. It was used for paying transaction fees in the Terra network. It was used for staking on the network. It was also required for having voting rights on the Terra network. It was also used to maintain the USD peg to the US dollars. And this was how Luna had a value. The majority of the Terra USD was invested in the Anchor protocol. Now, Anchor protocol was a decentralized finance platform which was built on the Terra network. It offered a range of financial products including savings, borrowings, and lendings. The platform was designed to give high interest rate and low transaction fees. In May 2022, $2 billion of Terra USD were unstaked from the Anchor protocol. This resulted in the value of USD dropping to 90 cents. It created a panic in the market and resulted in more USDs being sold and more Luna being minted or created. This triggered a drop in the value of Luna, and in a matter of weeks, Luna lost 99.99% of its value. Both Luna and Terra USD were delisted by the crypto exchanges. It is not very clear why this happened. It could have been driven by the US interest rate hikes, or could also be an attack on the network. So even though stable coins seem safer on the face of it, they are subject to a number of vulnerabilities, and they are not as stable as it sounds. In our next lecture, we will talk about smart contracts. Thank you. Welcome back. In the last lecture, we looked at stable coins. In this lecture, we will look into tokens and initial coin offerings. In the context of blockchain, a token refers to a digital asset that is created and managed on a blockchain. Tokens can represent a variety of assets, including cryptocurrencies, digital assets, or physical assets. Tokens could also represent a claim on the service provided by the issuer of the token. Tokens are usually created on the blockchains and they can be traded on crypto exchanges. Initial coin offerings or ICOs, and sometimes even referred as token sale, is a way for a company to raise funds without losing the stake in the company. In the traditional form of fundraising, a company raises funds via equity, debt, or via pre-ordering or pre-sales. In case of equities, the investor invests money in a company in return of shares or a piece of equity in that company. This gives the investor a right to the profits of the firm and also voting rights. The value of the shares is primarily driven by these features. A debt instrument allows the investor a right to receive interest during the period when the instrument is held and to also receive full principal at the end of the period. A pre-sale or a pre-order allows the user to pay now and get goods or services in future. Generally, the investors are given deep discounts. ICOs, though named similarly to an IPO, works a bit differently. Companies will create a white paper on the product or service they will offer, and then the ICOs have been announced. The investor can purchase the tokens and in return will get access to the product or service in future, or will be able to sell it once the tokens have been listed on the exchanges. ICO does not give investor any voting rights, and the value of the token depends on the success of the project. So it doesn't offer the investor the benefits that an equity or a debt instrument would, but there is a high upside gain. The investments, though, will be highly risky and highly speculative in nature. Now, broadly speaking, there are two ways in which you could achieve a token sale. One, where the token is being classified as a security, and second, where the token is treated as a utility token. If the token falls under the securities category, they will have to comply by the rules that are applicable to a regular security. Now, there could be restrictions on who the token is being sold, and there also be a lot of disclosure requirements. If the token is not treated as a security, they will have more freedom in terms of whom to sell the token to, and also in terms of the private and public sale. Deciding on which token is a security and which one is not could be tricky at times. In the US, the SEC has a long-standing test to check if the asset is a security or not, and this is known as the Howey test. This is based on the 1946 Supreme Court ruling on determining what is a security. Though it could get a bit complex, but at a high level, an investment is treated as a security if the person invests money in a common enterprise and expects the profits solely from the efforts of the promoter or the third party. Now, this definition will pretty much bring in all the tokens under the definition of security. Potentially, utility tokens are the only ones which could be treated out of scope. Most countries, however, do not have a strong regulatory framework around tokens and cryptocurrencies. Some countries have outrightly banned it, whereas some are still working on how to regulate these instruments. Because of the lack of regulations and the ease with which ICOs can be launched, there is very little that is stopping the scammers. As per a study, around 80% of the ICOs launched were scams. It is difficult to estimate the actual amount lost due to ICO scams, but one study puts the number as high as 10.2 billion globally. These scams can be classified under multiple categories. The biggest ones include the below. Exit scams are one where the issuer disappears after launching the ICOs. Phishing scams are the ones where the scammer steals information about the investor and takes hold of the crypto's trading account. Under the Ponzi schemes, the scammers dupe new investors into giving them the money and pass a part of that to the earlier investors as returns. Under the pump and dump, the scammers would artificially pump up the prices by providing misleading and incorrect information, and once the prices increase, the individual sells their holdings. Pre-mine scams are those where the developers and promoters share the unsold tokens amongst themselves instead of burning the unsold tokens. Now, this is a scam for the investors as they are not aware of the higher token circulation, which in turn leads to an artificially price hike. Now, you would notice that these scams are also applicable to all the other assets in the market. But due to the lack of regulations, these remain unchecked in the ICO space. In spite of these large scams, billions of dollars have been raised via ICOs. Also, the regulators, especially the SEC, has been increasingly working on improving the regulations around ICOs and cryptocurrencies. The same has been followed by many of the regulators across the world. In the next lecture, we will look into smart contracts. Thank you. Welcome back. An important term to understand with regards to blockchain is that of a smart contract. Smart contracts help extend blockchain's utility into a much wider area and way beyond the cryptocurrencies. Before understanding what a smart contract is, let's understand what a contract is. So when we say a contract, we mean it as an agreement between two or more parties, outlining the terms and conditions of their relationship. Now, these could be related to the business transactions, employment agreement, real estate, or personal matters. Smart contracts are computer programs that have been designed to automatically enforce itself. These are essentially programs that run on the blockchain. As a concept, smart contracts were first introduced in 1994 by an American computer scientist called Nick Szabo. He was also the creator of BitGold, which was created 10 years before Bitcoin. Nick called smart contracts as smart when compared to a regular paper contract, and this was primarily because these smart contracts could auto-execute. These are not necessarily intelligent contracts that could execute complex contracts. The example that Nick used was that of a vending machine. So when we pay a certain amount and choose a certain product, the vending machine will deliver that product. Now let's take an example. Let's suppose a store and its supplier enter into a smart contract. The contract is to pay the supplier a certain sum of money if the supplier delivers a certain quantity of product on a certain date. The smart contract will then be coded and relayed onto a blockchain, for example, an Ethereum blockchain. The code would be verified by the participants in the blockchain, and the parties, that's the supplier and the store, will have to pay a certain fee. Once the goods have been delivered as per the terms of the agreement, the smart contract will auto-execute and the supplier will receive the payment. Smart contracts offer a lot of benefits. The biggest benefit that a smart contract offers is that of an automation. It is interruption-free and no third party can change it. Smart contracts also work on networks with an immutable ledger, one that is encrypted and secure. Additionally, the whole system is trustless. That is, there is no need to trust any third party. So in our early example, we looked at the store and the supplier. In that case, the parties do not have to worry about the conditions not being met or the risk of not receiving the payment. This will help the parties to transact with any entity that is not even known to them. Since there are no intermediaries involved, except for the blockchain's participants, the smart contracts are highly cost effective. Once the smart contracts have been coded, they will operate and get executed as per the code. Of course, one needs to ensure that they have been coded correctly. There are a large number of use cases for smart contracts. Traditional financial services can be transformed in multiple ways. For example, in case of an insurance claim, the company can directly verify the details and process the payments when certain conditions are met. Smart contracts will also enable easy and uniform record keeping across organizations. This in turn helps in lowering the cost of auditing as well as reporting. Smart contracts can also help with the digital identity verification and make the KYC process more interoperable. Smart contracts can help improve the mortgage and loan processes. It can bring in the automation in the approval process. If KYC is automated and the record keeping is performed on blockchain, the entire approval process can be quick. By using the smart contracts, supply chain can also be improved manifold. For example, it will be used to track the item within the supply chain with full visibility and transparency. It also reduces the cost of verification and also the chances of theft and fraud. Another important area where smart contracts play a critical role is that of an escrow. When we say escrow, we mean a third party that holds the assets on behalf of the parties involved. For example, if party A wants to sell its car to party B, it may require a third party, let's say party C, to act as an arbitrator to guarantee the payment. Party B can transfer the funds to party C, who in turn will pay party A only when B receives the car. This way, both the parties do not need to worry about the non-performance of the agreement by either side. The smart contracts can remove the requirement of the arbitrator and thus reduce the cost. Smart contracts can be useful in many other fields like health, gaming, and even useful for governments. We will look at the application or the use cases of blockchain in much more detail in the next section. Thank you. Welcome back. In this lecture, we will look into non-fungible tokens. But before understanding that, it's worth understanding the difference between fungible and non-fungible assets. A fungible asset is an asset that is interchangeable with other assets which are of the same type, quality, and value. In other words, each unit of an asset is equivalent to the other unit, and there is no difference in terms of their quality, quantity, and value. So a $20 bill can be exchanged for another $20 bill, and there is no distinction between the two. Not only that, a $20 bill can be exchanged for two $10 bills or four $5 bills. The examples of fungible tokens also include securities, for example, treasury bills. It also includes commodities like gold, silver, or oil. And this also includes cryptocurrencies, bitcoins, or Ethereum. A non-fungible asset, on the other hand, is something that cannot be replaced with another asset. This includes real estate, antique collections, art, or even other collectibles. Each of these will have its own unique value. A non-fungible token or NFT is a non-fungible asset that is in digital form and can be stored and transferred on a blockchain network. NFTs could represent ownership of a unique item or a piece which includes an artwork, royalty, tweets, or even some videos. These are typically created on a blockchain and the ownership is transferred via blockchain. This helps in maintaining the transparency in the transfer of ownership and also in ensuring that these are not replicated or copied. NFTs are created via cryptography, and the process of creating tokens is called as minting. Anyone with a modest amount of money to spend can mint an NFT. One could be an artist, an entrepreneur, a musician, or a company, and any of them can create an NFT by using minting tools that are available on the NFT platforms. A typical process of creating an NFT would start with choosing a marketplace where the NFT is to be created. Now, there are tons of NFT marketplaces, and some of the more popular ones include OpenSea, SoulSea, and Rarible. Some of these marketplaces are focused on specific type of assets like art, whereas some would be more broad-based. And again, some of these could charge you a fixed fee, whereas some could be a value of the NFT. And there are some which would be a combination of the two. Once we choose the marketplace, the next step is to create a wallet for cryptocurrency and for the NFT marketplace. An important consideration here would be to select a wallet that is compatible with both the blockchain as well as the NFT marketplace. A wallet then needs to be connected to the NFT marketplace. The next step would be to convert the asset into NFT on the platform. The NFT platforms will have a number of tools which will help in converting the asset into the NFTs. Again, the asset could be anything, including artwork, ticket to events, memes, games, or even a real-life item like valuable collectible. Once the asset has been converted to an NFT, the next step would be to pay the fees and decide on the base price or the price range for selling the asset. Once the asset is bought by the buyer, the proceeds are transferred to the crypto wallets. NFTs have been growing in popularity, and its use case spreads across multiple industries. So in case of real estate, one potential use case of NFT is the sale and transfer of property ownership. The other use case would be into fractional ownership in a property, which will give access to the owners of the NFTs to the rent and the proceeds from the transfer of property. NFTs could also be used to create new revenue stream for artists and creators. This would allow them to sell the ownership of the royalties directly to fans or investors. This will provide a new way for the artists to monetize their work, particularly those who do not have access to traditional financing. An example could include NFTs, which could represent an ownership of a percentage of royalties generated from a song. NFTs have become increasingly popular in the gaming industry, especially games that involve collecting or trading virtual items. So these could be used for in-game assets like weapons or characters, and these could then be traded by the gamers. NFTs can also be used in the space of digital art, music videos, and other forms of digital content. Since NFTs can provide a proof of ownership and also the authenticity of the digital items, it helps in ensuring that the assets are not forged or copied. NFTs also have the potential to revolutionize the fashion industry. NFTs could provide an opportunity for the fashion brands with new ways to authenticate and sell limited edition clothing and accessories. Some fashion brands have already started experimenting with it. For example, Gucci had launched virtual sneakers. Burberry had also experimented with NFTs by creating virtual hoodies. Now, these are not the only ones, and there are many other companies using NFTs in the fashion industry. Apart from the ones that we covered, there are many other use cases of NFTs, like licenses and tickets to events, etc. And its adoption is growing exponentially. However, NFTs are still in the infant stage. There are issues with high volatility and concerns around frauds and scams. Also, the issues that concern blockchains in general, like regulatory concerns or concerns about the environmental impact, these also have impact on the NFTs. In spite of that, NFTs are growing in popularity. This brings us to the end of this section. In the next section, we will look at the application of blockchain in other industries, like health, insurance, real estate, and finance. Thank you. Welcome back. In this section, we will look at some of the applications of blockchain outside the crypto space. The way we will look at these topics is by looking at some of the challenges faced by these industries and how blockchain can be used to tackle those challenges. In this lecture, we will look at health industry. One of the biggest challenges faced by the health industry is the data storage and sharing. In a world where we have a quick and easy access to data relating to our daily lives, we struggle to have access to our own medical records. This is partly due to the strong regulations around privacy and sharing of health records. An individual's health records are scattered across multiple organizations over his or her lifetime. Due to lack of sharing of data across organizations, there is no clear and complete record of an individual's health record. The hospitals have to rely on the patients to provide the information, which in most cases is either not fully accurate or not available at all. As per a study, in the US, the third largest cause of death during surgery is wrong diagnosis, and that is partly driven by the lack of accurate and complete data. Also, it is estimated that in US alone, around 760 billion to 900 billion are lost due to administrative complexities and failure of healthcare coordination. Now, this is where blockchains can help. Blockchains, due to its immutable record and single source of truth, will allow to maintain a near accurate data of the record of the patient's health. Now, let's take an example. Suppose an individual goes to an hospital and needs to submit all his past health records to the hospital. If his records were been updated on a blockchain network, it would have looked something like this. So when he visits a physician, that diagnosis gets recorded on a network. Then the subsequent blocks will include any medicines that he bought from the pharmacies. The blocks would also include any surgeries or any dental visits. Now, all of this information can be provided by the individual to the hospital directly. And now the hospital will have a complete and accurate record of his health. The other important challenge faced is the authenticity of medicines and other health equipments. When a medicine has been bought by an individual, it passes through a number of parties. These will include, at a minimum, a manufacturer, transport companies, wholesalers, and pharmacies. Blockchain technology can help create an immutable link and record of the transactions. So when a manufacturer produces the drug, he will create a unique code which will be stored on the network. The delivery company will be able to verify the origin of the product and log the transaction in the next block. This recording of transactions will continue until the individual gets the medicines from the pharmacy. The individual can then verify the entire chain and the origin of the medicines for its authenticity. Now, this logic can be extended to any other area of supply chain management, not just health. Also, the use of blockchains can be extended to many more areas within the health industry as well. In our next lecture, we will look at how blockchains could play a very important role in real estate. Thank you. Welcome back. Investing in real estate is challenging. Now, anyone who has already invested or is trying to invest in real estate knows what I'm referring to. But if we were to dig deeper, most of the challenges in real estate are driven by two causes. One is a lack of transparency, and second is non-divisibility of the asset, or in other words, lack of fractional ownership. Lack of transparency leads to multiple challenges. Some of these include inaccurate and outdated information, high fees and commissions, delay in the mortgage approval process, and property disputes. Blockchains can help tackle these challenges. By creating an immutable ledger, blockchains can become the single source of truth with the latest information. Since the information is readily available, the buyers and the sellers can communicate with each other directly. The info is not only about the seller and the property, but also about the buyer. With easy availability of data, we could eliminate the need for brokers and agent and thus save on the brokerage costs. If the information is available real time and is accurate and can be trusted, it vastly helps the lenders to come to a quick conclusion. This speedifies the approval process. The availability of data could also help with resolving the property disputes and also help reduce the administrative costs. The next important aspect is real estate tokenization. It is a process of fractionalization of the real estate property into tokens and store them on the decentralized database, like a blockchain. Real estate tokens could take any form. For example, it could be an ownership in a part of a property, could be an equity interest in the entity that holds the real estate, could be interest in a debt secured by the property, or could be the right to share in the profits generated by the property. Of course, there are other instruments for investing, for example, a REIT or a mortgage-backed security. But in this case, we can bypass the central third parties and can have more clear information. Tokenization helps reducing the barriers of entry, as you can invest with a much lower amount. It helps in reducing the transaction cost. And it can also help in creating more liquidity, as one can sell and buy smaller stakes more easily than buying or selling the entire property. In our next lecture, we'll look at how blockchains help in solving the challenges faced in the insurance industry. Thank you. Welcome back. Similar to real estate and health, insurance industry also faces multiple challenges, which are primarily driven by lack of transparency and non-availability of data. These challenges primarily include false claims, high administrative cost, and delay in settlement. With the ease in the availability of the health records and transparency thereof, it will be much more easier to detect frauds, and the application process will be made simple. Due to the availability of real-time data and verified records, there can be customization and flexibility built into the system. It will also simplify the reinsurance and microinsurance, thereby reducing the risks for the insurance company. All of this will help reduce the cost for the insurance companies, which in turn will reduce the premium that we pay on the policies. Increase in transparency will help increase the insurance coverage in society, and blockchains can play a key role in it. Thank you. Welcome back. When we say finance, we are not just referring to banks, but to the entire financial industry. It involves clearing and settlement, insurance, asset management, lending and payments, and also the regulatory aspects, among other things. With the highly programmable nature of blockchains and smart contracts, the technology can be extended to multiple areas in finance. With the underlying aspects of blockchain technology like decentralization, consensus, immutability, and faster transaction processing, the existing business models can revamp and make the business transactions more fluid than ever. It also helps in the introduction of new products and services. Further, fractionalization and tokenization helps in opening up new avenues and enhances the scalability of the activity. We looked at insurance in our previous lecture. Now let's look at some of the other use cases of blockchain in financial industry. Know Your Customer, or KYC, is a due diligence process that helps financial companies to verify the customer's identity and the risks involved. KYC is not just restricted to the onboarding process, but also to the ongoing activity. KYC helps in establishing the customer's risk factors and prevent fraud. It also helps in complying with the anti-money laundering laws. The anti-money laundering primarily focuses on preventing money laundering and terror financing. Both KYC and AML require the verification of customers' identity. The traditional process of KYC is repetitive, expensive, and time-consuming. For example, when a person wants to open a bank account, he or she needs to provide all the documents to the bank. The bank will then use an intermediary for the verification process. When the same person opens an account with another bank, the same process is repeated. The financial institutions further have to spend time and resources to ensure that the data is accurate and up to date. If the same information were available on a blockchain, where clients can upload their data and get their identity verified, then the same information can be used by all the financial institutions. The financial institutions can be ensured that they are receiving a single source of truth as well as the latest information. Another area where blockchains can play an important role is asset and wealth management. Asset management refers to businesses wherein financial institutions manage money and assets on behalf of institutions, corporations, or high net worth individuals. Wealth management is similar to asset management, but it's generally for individuals and families and extends beyond managing assets. For example, they could look at tax matters, inheritance, etc. An asset manager faces multiple challenges. Some of these include a slow and complex process, involvement of multiple intermediaries, and then dispute management. Asset managers can greatly benefit from blockchain technology, which provides them with a single source of truth. With blockchain technology, the asset manager can be ensured about an accurate information about the security in which the manager is investing. Suppose the asset manager wants to invest in mortgage-backed security, which is backed by multiple mortgage loans. If this was implemented on a blockchain technology, each of these underlying loans would be on a separate smart contract. The smart contracts will hold the information of the loan, and the asset manager will be able to drill down into the MBS and get the information of the underlying loans. This will also include any information on any changes that were made on the loans, for example, a change in the FICO score. This helps the manager to assess the risk on the instrument with higher level of accuracy. The asset manager is also benefited by lower cost. Since the information is more easily available and the risks are clearly understood, the asset manager can take the protections accordingly. Also, there is less resource spent in getting the latest information and on performing the repetitive tasks. It also opens up new avenues for investment. For example, the asset manager can now look at asset classes like cryptos and NFTs. Also, with the fractionalization of the assets, the asset manager can now take exposure in multiple asset classes, which otherwise would have been avoided. Another area where blockchains are playing an increasingly important role is clearing and settlements. Clearing and settlement is a process by which the financial trades are processed. The end state of this process involves buyer getting the ownership of the securities and the seller receiving the money against the securities sold. The process is typically managed by intermediaries like clearing houses, custodian banks, clearing members, and also sub-brokers in some cases. Blockchain technology is revolutionizing the clearing and settlement of trades by providing more efficient, secure, and transparent ways to process the trades. Traditionally, the clearing and settlement process involves a complex network of intermediaries like banks, brokers, and clearing houses. This leads to delays, errors, and higher costs. Also, much of clearing now happens on automated clearing process in the clearing houses, which are also called as ACHs. Blockchain technology can help in streamlining those processes. There are many ways in which the blockchain technology can help in this space. Currently, the post-trade settlement process tends to be slow and inefficient. This is mainly due to the nature of dispersed information in the trading processes. Most of the intermediaries use systems that are incompatible with each other, and thus leading to duplication of records and efforts involved in reconciling the data. This is one of the main reasons for a longer settlement cycle like T+2 and T+3. In contrast, the blockchain technology can help reduce the information cost by providing a common public ledger that can be accessed and shared by all the participants. This can also allow the systems to provide for a more flexible settlement times. It can also allow for the time-varying settlement cycles, depending upon the needs of the market, and not driven by the technological constraints. Blockchains could utilize smart contracts to automate the clearing and settlement of trades. This will help in the elimination of the intermediaries in the process. With the introduction of peer-to-peer transactions, the automation of the settlement with the use of settlement contracts, and reducing the settlement cycles, blockchain technology can help with the reduction of the counterparty and settlement risks. Blockchains provide for a greater transparency and also an auditable record for all the transactions, thereby reducing the risks of fraud. There are various clearinghouses and exchanges who are experimenting with the blockchain technology. Recently, DTCC has introduced blockchain technology for clearing of its trades. Currently, around 100,000 trades are being managed by DTCC every day through its blockchain technology network. Though this only forms a fraction of its overall activity, it is expected to extend to a much larger number in future. Outside the areas that we covered, blockchains can also help in multiple other areas of finance, like payments, loans, regulatory, and compliance requirements. Thank you.